Hello everyone, welcome back to my channel. So in this video we are going to learn about static, which is also called memoryless, and dynamic, which is also called with memory. Static and dynamic systems. Okay, so in this video we are going to learn about this is the classification of the system, one of the classification of the system. Okay, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So static system, a system is said to be static. So the name only specifies it is static. Static means it depends only on the present value. Okay, a system is said to be static or memoryless. Static or memoryless if its output at any instant, depends on input at that instant only. Okay, so if your system output depends only on the input at that instant only, then that type of system is said to be static. Okay, since there is no storage, there is no storage of previous inputs or previous outputs, so it is called as memoryless. If the output depends on past or future values of input, then that type of system is called as dynamic system, or it is also called with memory. Okay, so this is simple classification. System output at any instant should depend only on the output. System output at any instant depend on the input at that instant only. If it depends on past or future values of input, that is, if it means output. If output depends on past or future values of input, then it is called as dynamic system. Okay, so let us see some examples. One by one we'll see the examples, then you'll understand very clearly. Suppose y of t is equal to t plus 1 whole square into x square of t. Okay, so t plus 1 whole square into x square of t. So if you observe here, the input at, suppose you take an example y of 1, so at the input at t is equal to 1. Okay, at t is equal to 1, so it depends since t is equal to 1, this becomes 4 into x square of 1. So the output at an instant t is equal to 1 depends on input at t is equal to 1. Similarly, you can take for t is equal to minus 1 as well. So y of minus 1 is equal to, this becomes 0 anyhow. Okay, suppose if you take t is equal to minus 2, so y of minus 2 is equal to minus 2 plus 1 whole square is minus 1 whole square, which is 1, multiplied by x square of minus 2 only. So the output at instant t is equal to minus 2 depends on input at t is equal to minus 2. That is, the output at any instant is depending on the input at that instant only. Hence we can say that this system is a static system. Suppose we will take an example second. Y of n is equal to x of minus n. Okay, so y of n is equal to x of minus n. So if you take y of 1, that is at an instant n is equal to 1. Instant means time. Okay, at instant means at time n is equal to 1. So it is equal to x of minus 1. So for 1, minus 1 is a past input. If the present input is, if the present value of output which you require is 1, then x of minus 1 will be passed to that. Okay, because minus 1 comes before 1. Okay, so on the timeline it becomes, so -1 0 1, so all the instants less than this are called as past values, and all the instance greater than this, suppose if you take the reference as 1, all the instance greater above this like 2, 3, 4 are called as future values of the input, and these are called as past values of the input. Okay, so this is called as past input. So now the output depending on past values of the input, so the system is dynamic. Suppose y of n is equal to x of n minus 1. Static or dynamic? So you have to tell me y of 1, n is equal to 1 if you take, is equal to x of 0. With respect to 1, 0 is a past input. So output at instant 1 is depending on the past input. Therefore the system is dynamic. Okay, so this is how, by taking some instance as examples, we can say whether the given system is static or dynamic. Suppose y of n is equal to x of 3n. So y of 1 at a instant n is equal to 1, so this is x of 3, right? X of 3. So with respect to 1, 3 is a future value. So future input, the output at instant n is equal to 1 is depending on future value of the input. Even if it is depending on future value of the input, it is said to be dynamic system only. So this system is dynamic system. Okay, so this system is dynamic system. We'll solve one more example. Suppose differentiation. Y of t is equal to d by dt of x of t. Differentiation. Static or dynamic? So it is dynamic always. Why? The differentiation always depends on initial conditions. So initial conditions represents the past stored value. Okay, past stored value of the energy storing elements. Okay, so energy storing is like A is equal to C into dV by dt. So this differential equation will be of this form only. Okay, so I is equal to C into dV by dt, that is voltage stored in the capacitor will be the past value, that will be the initial condition of the capacitor. Okay, so always the differentiation is a dynamic system. Similarly, integration is also a dynamic system. Sixth one, y of t is equal to integral minus infinity to t x of t dt is also a dynamic system, because it depends on all the values from minus infinity to t. Okay, so that means y of 1, if you take y of 1, it is depending on minus infinity to 1 x of t dt, that is it is depending all the values from minus infinity to 1. But actually for system to be static, it should depend only at 1, that is x of 1. It should depend only on x of 1, but since it is depending on all the values from minus infinity to 1, it is also a dynamic system. Okay, so this is how we can classify a given system as either static system or dynamic system. It purely depends on the output at any instant should depend on input at that instant only for a system to be static. Okay.